Hi everyone, welcome to this video where we will learn about how to implement elasticity, high availability and monitoring in an AWS infrastructure. So before we begin with today's video, let me give a quick introduction about myself. I am Aishwarya Sood, working as a lead coach in the AWS domain at Ethnos. I'm an Amazon authorized instructor, AWS Academy accredited educator, and also 4x AWS certified. You can connect with me on LinkedIn. The profile name I have given here. Also, if you want to quickly view my profile, you can scan this QR code in order to check it out. Now, what are we gonna cover in this video? We'll talk about highly available architectures and the importance of high availability, and we'll see that how do we actually build the high availability in an architecture, starting from why to monitor, how to monitor. So we'll discuss about Amazon CloudWatch, Amazon CloudTrail. Then we'll discuss about how to implement auto scaling in an architecture, and how do we implement the load balancing in an architecture. And finally, we'll build an architecture which will be able to dynamically scale based on multiple factors, and also the load balancing will be implemented in that, and eventually that architecture will be highly available. So let's begin with the first topic for today. Have a look at this architecture. What we have here is in a single region, in a single availability zone. Okay, our architecture is there. So we have created a VPC in our region. Okay, within that we have two subnets, one public subnet and one private subnet, and one EC2 in that, and a route table for this public subnet and the internet gateway to let the resources talk to the internet, and finally they are talking, and this is the route table for the public subnet with the internet gateway entry. So this is a very basic architecture, no high availability, nothing at all. This is just a single easy architecture. So why is there no high availability? Because see that what if this EC2 fails, or what if this availability zone fails? Do we have a backup? No, the application will go down and the users will not be able to access it, since the component has failed and we don't have any sort of backup. Now, no business wants failure in its operational systems. Of course, who will want that, right? And failures create the downtime, which is nothing but a period of time when your system is not available for use or is unresponsive. And downtime will happen only because of these things, when we don't have any sort of other component to take up the load. So downtime will hamper the business output and the performance. And for big corporations, each minute of downtime can cost thousands of dollars. Have a look at another architecture, better one. Slide. You can see here the differences in the first one and the second one. Right? This was just a single AZ. Now we have a slightly bigger architecture. So in order to avoid, like we discussed, that no business wants such downtimes in their architecture. So as a best practice, we have to avoid single points of failure and build high availability in our architecture. So what is high availability exactly is? It is one that can the system is highly available. It is said to be highly available when it can withstand some measures of degradation while remaining available. So basically, if I say that, this is a highly available architecture, what's happening here? I have multiple servers spread across multiple availability zones, because we have two AZs here. So even if one server goes off, we have another to take up the load. Even if one availability zone goes off, we have another availability zone to take up the load. And in that availability zone, as well, we have multiple servers. It's not just the one. So for the databases also, we have multiple standby and the replica that are there. So there is no single point of failure. Even if the AZ or the server goes off, the another will be there to take up the load. Although there might be little degradation in the performance, because let's say initially if your application is running on 4 servers, in case of failure of one server, it might be running on 3 servers, or it might be running on 2 servers. So little amount of degradation might be there in the performance, but at least it will be available. There will be no downtime, that users will still be able to access the application. So in such a highly available system, downtime is minimized as much as possible and minimal human intervention is required. So we'll learn that how this is, most of it is automated and why there is no human intervention in the upcoming slide. Now, how do we measure the availability of a system? We are saying that my system should be highly available. Let's say person A says my system is highly available. Person B also says that. But how do we compare that? Which one has more high availability? So it is measured in the number of nines. When somebody says there is 99% availability, we get to know that okay, the maximum disruption that can happen in such a system is this is a possible one. Okay, this is just a probability, it is not guaranteed, but it's just possible that if something happens, it will not last longer than this much. Now, it is not going to happen in a stretch. It might be 5 minutes in once, then 2 hours, or maybe 3 hours, something like that. But a total cannot exceed more than 3 days and 15 hours. If somebody says that their system has 5 nines of availability, what we will understand is okay, this is very highly available. The maximum possible disruption per year is just 5 minutes. Okay, it might be few seconds in once, it might be few seconds in another time, right? But the maximum that can happen is just 5 minutes. And different kinds of applications has different kinds of availability requirements. For example, this 5 nines of availability is for really critical applications, for example the ATM transactions. So that sort of application, even if it is off for a few seconds, it can lead to huge loss of money. So in those kind of systems, we build more and more availability. So now that we understand that what is the importance of high availability, the question is how to achieve it. So for that, we have to continuously monitor our infrastructure to maintain the availability of our architecture. So how do we get to know that something needs to change or something that's affecting the user experience because of low availability of our resources? The answer is monitoring. Okay, so basically the operational health, that how the resources are performing, are they okay, and the application performance, how the application is performing and our resources, and how much resources are being utilized, are they overutilized, are they underutilized, or any sort of security auditing, that who is doing what. Right, like is there any sort of unintended excess that is happening that I may look for. Okay, so all these things I get to know only with the monitoring. So monitoring our environment is one of the most important things that we have to think about when creating the architecture. We will always need a way to keep the track of how our resources, applications are operating and they are performing. So monitoring gives you all these information and the answers to all these questions. So eventually you will get to know that does something need to change. Once you get the answers to all these questions, you will get to know okay, is it the required performance and the utilization that I expected or not. So maybe you will get to know that okay, this is something that we can change in order to get the desired outcome. So first service that can be used for monitoring is Amazon CloudWatch. What does it do is it collects the metrics from your infrastructure, which can be, let's say, as simple as CPU utilization, that how much CPU is being utilized by an EC2 instance. Okay, that is just one example. There are multiple metrics. Then it monitor. Okay, you can visualize applications and infrastructure with the CloudWatch dashboards, where you can see all the data in a single place, and you can set up the CloudWatch alarms, where it can take some action, or it can send some notification in conjunction with the SNS. If something is required, then it can act upon something, like if something is happening and you want to further automate the response action in respect to the event that has happened, you can do that as well. So the auto scaling of EC2 can be working in conjunction with this, and you can even analyze up to 1 second metrics, and extended data retention also you can have up to 15 months, and real-time analysis with the CloudWatch metric math. So there are a lot of components that are there in CloudWatch. Few of them I would like to tell you so as to get a basic understanding of CloudWatch. Here we go. I have drawn a quick diagram to make you understand in a simple way. So let's say we have an EC2 instance on which an application is running. So what is a metric in this case? Metric might be a CPU utilization that I'm monitoring for this EC2 instance. That how much CPU is being utilized by this EC2. Now, what will be the logs in this case? Logs might be any sort of errors or the print statements that are getting generated from this application that is running on this EC2. Then what will be the events? Events will be any sort of change that is happening to my resource. That is in this case EC2. So let's say EC2 was in the running state and it goes to the stop state. This is one event. From running to stop, it is one event. Now, what will be a rule in this case? So rule can be like I'll give a statement which will match the event with the rule. Okay, I will say that if the instance state is stop, okay, do this, send the information to the target. So some sort of rule I will specify. It will check that if the incoming event is matching with the rule. Okay, if it is not matching, like let's say it went from run to terminate state, that is not matching with my rule because I specified as run to stop. So it will ignore that. But what if it is matching with my rule? It is going from run to stop state. Then it will pass on the information to a target. So which is nothing but any other AWS service. It might be AWS Lambda, it might be SNS or anything which will take the further action. So this whole will be automated. All you need to do is set up the rule once and specify what you exactly want, and further actions will be automated by it all the time. Okay, so these are the basic components of CloudWatch that you need to know: metrics, logs, events, rules, and the targets. Okay, so this will be good enough to understand the CloudWatch. Next we have is CloudTrail. So this is another monitoring tool that we have. So it helps you answer the questions requiring a detailed analysis. We can store our CloudTrail API usage logs in the S3 bucket, and it basically tells that who is doing what in your AWS environment. CloudWatch was telling about how the resources are performing and what is your the utilization and everything. CloudTrail is telling you who is doing what in your AWS account. That is the basic difference. So you can remember with the CloudTrail the keyword as API calls, that it records all the API calls happening on your AWS account. So you can analyze the logs that are captured by the CloudTrail later to answer the compelling questions such as why was a long running instance terminated and who terminated it. Okay, and who changed the security group configuration, what activities were denied due to lack of permissions, who logged into your AWS account, who created an EC2 instance, who created a S3 bucket, who uploaded the data into that. Multiple such questions you can get the answers from the Amazon CloudTrail. Okay, so this is another monitoring tool that can be used. Another thing that we have is autoscaling. So now we know that what's happening with our AWS environment, right? But like how are the resources performing? But we need a solution to manage the resource capacity automatically based on the live environmental changes. So for that we have autoscaling. Now think about a situation where you were trying to access a website but it didn't load and it kept timing out. So that might be because the website might have been receiving more requests than it was able to handle. EC2 instance was, let's say, capable of handling 1 lakh requests. Now at some particular time it is getting 1.5 lakh of requests. So what will it do with those extra 50k requests? Those will not be able to get served by the EC2, right? So in such cases, what do we do? EC2 auto scaling can help you in that case. It can help you automatically add or remove more EC2 instances or lessen the number of EC2s in response to the changing application demand. For example, if the demand is increasing, it will increase the number of EC2s. When the workload is decreasing, it will decrease the number of EC2s, so that you don't have to face such issues where your users were not able to get the response from your application. So it can automatically scale the instances in and out, like how you can see in this diagram. which helps us in maintaining the availability of our application. There are different scaling policies and the types that you can choose to configure. For example, dynamic scaling, scheduled scaling, and predictive scaling. All of them have different use cases, and there are other components to configure as well. For example, launch templates, auto scaling groups, etc. So all of this you set up when we do the auto scaling. Much of these things we'll cover in our today's demo as well, and you will understand it even better. So in the auto scaling also, like we have two types of auto scaling on AWS if we say. One is AWS auto scaling, which provides the application scaling for multiple resources, which include EC2, DynamoDB, Aurora, and many more across multiple services in short intervals. Whereas the one that we just talked about was the EC2 auto scaling, which helps us ensure that we have the correct number of EC2 instances available to handle the load of our application. Now, moving towards the next topic for today's video, we now that we have enough resources to handle the application workload, how we will make sure that there is even distribution of the traffic among all of them, because we knew that okay, this is how my resources are performing, and based on that I have enough number of resources as well. But now once I have enough number of resources, how will I make sure that all of them are getting the even distribution of the traffic? So load balancers come into picture that time. It will distribute the incoming application traffic across all my underlying resources, which might be the EC2 instances, which might be the containers, which might be the IP addresses, or which might be the Lambda functions. So it can balance the load across multiple underlying targets in a single availability zone as well as in multiple availability zone through one feature of load balancers that is known as cross zone load balancing. Also, it is a managed component of AWS, so it scales your load balancer as the traffic to your application changes over time. It can automatically scale to most workloads. So eventually, it helps you in achieving the high availability and automatic scaling. It doesn't do the automatic scaling. It, in conjunction with the auto scaling, does the automatic scaling. Okay, so every service has its own purpose. High availability, automatic scaling, monitoring, everything, and the load balancing. Multiple services will work together to achieve all of these things. And with the load balancer, we have different types of load balancers. We have application load balancer, network load balancer, and the gateway load balancer. How to decide that which one to choose? We have to consider what sort of application we are having and what are the protocols that we need to do the traffic sending on. So application load balancer follows and supports some other protocols like HTTP and HTTPS. Gateway load balancer is for some other purpose, and network load balancer also supports the other protocols like TCP and UDP. So you have to understand first the types of load balancers, that what do each of them is used for what sort of applications, and then evaluate what sort of application you are having, and finally you will have the answer that for your application what type of load balancer you have to use. So these were some of the resources that we need to maintain high availability in our architecture. Quick overview, we discussed about highly available architectures, and we discussed how do we measure the high availability, and we discussed the importance of monitoring. We discussed how to monitor and how to do the security auditing to know who is doing what, and we discussed how to perform the auto scaling in AWS, specifically on the EC2 instances, and then we discussed about the load balancing. So it was a quick overview of all of these components. Now we will discuss about our architecture, which is involving all of these resources, and then we will create the same architecture on AWS, and we'll see how does it work. So here we have an architecture. What's happening here is we are using all of these services together that we learned today. EC2 auto scaling, CloudWatch, load balancers, they work individually very strong, right? Load balancer has a good purpose, auto scaling also, and CloudWatch also. But when they work together, they work even stronger. What do they do when they work together is they help us in achieving the dynamic scaling and high availability in our architecture. So what's happening here in this architecture is there's a load balancer which is used to transfer the load across the underlying targets, and for monitoring these underlying targets we have CloudWatch, that what is the CPU being utilized by them. So we set up a alarm in this, that if the CPU utilization goes beyond 60% for 5 minutes, it will then inform the auto scaling. So what auto scaling is doing? Auto scaling based on the information received by CloudWatch and the policies set up in the auto scaling, it is launching more instances. And similarly, if there is a lack of like if there is no need of that much of EC2 instances and there is lower CPU utilization, it will decrease the number of EC2s. So that's how all of them are working together. And whenever one thing more, and whenever a new EC2s gets launched by auto scaling, it is automatically registered by the load balancer also. You do not have to do anything manually here. All you have to do is set up once and further actions will be happening all automatically. So let's go to the AWS console and we will build a similar architecture and see how does it work exactly on the AWS console. So I have already logged into my console. What I will do is, as a prerequisite, I have done nothing here, but just one security group I have created, which I'll be using with my load balancer. So that security group is allowing all the HTTP and HTTPS traffic from the internet. So when you are trying to perform the demo, you can create a similar security group. So as another step, what we will do is we'll first create an EC2 instance, okay, which is our very first EC2, and then we will proceed by creating the auto scaling groups. Let's go to the EC2 console and quickly create a EC2 instance. So I don't have any so much specific requirements for it. I'll just go ahead and launch an instance with most of the default settings. Let's see what all things do we have here. So I'll name it as first so that I can identify it easily. And I'll go ahead with the Linux AMI. I'll go ahead with the T2.micro. Keep here, let me choose it, but I won't be anyway needing it. Okay. And security group, yes, we can create a new one. For EC2, I didn't create anything as of now. So what I can allow here is allow the SSH traffic just from my IP, and we can allow the HTTPS and HTTP traffic from the internet. That's okay. And apart from that, storage, let it be default, and other advanced details, we don't do anything specific. User data I will give because I want to host a small web page onto this EC2. So I have the user data ready. I'll copy this user data and we'll give it here. What this user data is gonna do is it will just host a web page which will say, hello world, I'm the first EC2 instance. So this one we will get from this EC2. Let's launch the EC2 instance. Here we go. Our instance is ready. Let's view it. Yeah, it is in the pending state, so soon it will be ready. In the meanwhile, let's go to the auto scaling group and begin creating our auto scaling configurations. What we'll do is we will click on create auto scaling group. We will give it a name. Let's say new ASG. Okay, we'll give it the name like that. Launch template is something that will specify that whatever EC2s will be launched by auto scaling group, what will be their configurations, right? So we have to specify something for that. As of now, I don't have any launch configuration or launch template. This is a previous one that I created, but one second. This is a previous one that I created, but I won't be using that. I'll create one from the scratch so that I can show you that how do we specify the details in this. In the launch template name, you can give anything. Let's say new ASG template, something you can give. Okay, and same description, you can give something. And then you specify what all EC2 instances you will be needing, like what will be the configurations. So you say AMI, which one you want. I'll go ahead with the Linux because even the first one had the same. Instance type, which one I want. I'll go ahead with the T2.micro, the common one. And keep here, let's choose the same one. Anyway, we won't be needing it. So subnet, we don't have any specific preference, so I'm not including it in the template as of now. Security group, I think we can choose the existing one itself, which we created for our initial EC2. So I'll go ahead and use the same launch wizard one. I think, yeah, this is the one. And any other network configuration, nothing we have. EBS volumes, one volume we have, 8 GB, that's okay. Tags, do we need to give anything? I'm not giving anything as of now. We can give it later if we need. Then spot instance, if you want, you can check here. Okay, any sort of role you want to give, you can choose that as well. Anything you want to give, you can give here. As of now, this is not of my use. I'm not giving anything, but I'll give the user data. Uh, One second, let me copy it. I'll give the user data, and this time I'll say I'm the new EC2 instance. Okay, so that we can identify later the differences between what is our new EC2, which one is our first EC2. So here I'm giving the new EC2. Then I'll click on create launch template, and I'll come back here, refresh, and here I go, new AST template. Now we can have versions of our launch template. As of now, it is a default, which is the first version. We can create a new version with different configurations, and we can use that as well. So let's go ahead, click on next. Okay, now in which VPC it should be kept? Okay, we are just choosing the default VPC because I don't have any other VPC here. AZs and subnets, I'll choose all of them now because initially I didn't choose, but here I'll say all the subnets and the AZs should be included. And then instance type requirements, if you need to change anything, you can give by overriding the launch template. Otherwise, you can click on next. Now, apart from this, what we are going to do? Now comes a load balancer things. See here, we were on this diagram. We have configured the auto scaling configurations to some extent. Now we are on to this level. We are specifying the load balancing details as well. So let's go back there. We do not want a load balancer, or we choose an existing load balancer, or we give a new load balancer. We'll say we want to give a new load balancer. Which load balancer you want to choose, application or network? We'll go ahead with the application. That is what we need as of now. What should be the name of the load balancer? It has taken automatically. If you want, you can give a customized name according to you. Otherwise, you can let it be whatever it is. So I'll keep it what it has given automatically. Then load balancer scheme. Should it be internal? Should it be internet facing? Now, what is the difference between them is internal is something, let me tell you first the internet facing. Internet facing is the one that takes the traffic from internet and passes it on to the public subnets. And internal is the one which takes the traffic from public subnets and passes it on to the private subnets. So while watching this video, if you are watching, and I am assuming that you are aware of basic networking concepts. If not, you can watch a separate video we have on that, or you can read a documentation just to get the idea, and then you can understand it better. So we need an internet facing, since in this load balancer, we are receiving the traffic from internet and giving it onto the public EC2s. Okay, so across which availability zones it should do the load balancing, we have included all. That's why it has selected all the all the availability zones and the subnets. At what port it should be listening? I am saying 80 port. This is a listener rule that is specified. And what should be the health checks associated with this load balancer? The default is EC2 that is checked. And do you want to the ELB health checks also? Then you can check. Otherwise, you can say default as it is. So a health check grace period, what does it say? The amount of time until EC2 auto scaling performs the first health check on new instances after they are put into service. So you can specify if you have any requirement for this, you can give the number of seconds. Otherwise, you can say 0. And nothing else we need here. We can click on next. Okay, something is okay. 1 second. I forgot to create a target group in this. In load balancer, we need to create a target group. Okay, what's that? It is nothing but a set of EC2s across which the load balancing will happen. Okay, so we need to give a target group. We need to add our EC2s that we have in this target group. Then the load balancer will be able to balance the traffic onto it. We'll be able to route the traffic onto it. So I will say new AST, and I will give the name as TG, so that we can identify it as a target group. And then we can click on next. Another issue, or is it all correct? Okay, it was all correct. Now we give the auto scaling information. Okay, that what should be the maximum size of the group, what should be the minimum size. For an auto scaling group, we specify the minimum capacity, maximum capacity, and the desired capacity. Minimum is that my auto scaling group will never go below this number. Okay, that my auto scaling group will always have at least this number of EC2s. Maximum is it will never go beyond this number. Okay, that no matter what the condition, even if it is needed, it should never launch more instances than this number. So I'll say maximum is 5. Desired, I will say 2. Okay, minimum also I can say 2. That's okay. You can give anything as per your requirement. So desired is what we want at the current point of time. How many EC2s do we want? Minimum, it will never go below this number. Maximum, it will never go beyond this number. But desired is something that we want right now. Scaling policies, on what basis our auto scaling group should be performing the auto scaling. We'll create a scaling policy, which we have here is target tracking. Here what will happen is I am choosing the CPU utilization as a metric. Okay, this is the most common one, and target value I'm setting as 20. That because I'm setting a lower target value just to show you the effect of all of these things. Otherwise we can keep a bigger value. So what it is gonna do is it will maintain this target. If my CPU utilization of my EC2s goes beyond 20, it will increase the number of EC2s. If it is going below 20, then it can decrease the number of EC2s. But I can make it only to scale out by disabling the scale in. Okay, it is up to me. I have multiple choices here. So we will just create a scale out policy, not for the scale in as of now. Okay, if you want to create scale in also, you can just uncheck this. Okay, so instances need how much time warm up before including in the metric? We say 0 seconds immediately as soon as they are created. They should be included in the metric. They should be up and running and working for the actual workload, and they should be counted in the metric as well. So that scaling policy we are creating. You remember here we were having something, if CPU utilization is greater than this much for 5 minutes. Similar thing we are configuring here in the auto scaling. Okay, this is a CloudWatch alarm. This will be automatically created with the policy. So we are specifying the details in the auto scaling. Now this will let us have a CloudWatch alarm. I'll show you later once we are done with this. The alarm will be created automatically. Notification, we don't want anything. So I'm clicking next. Tags also nothing. And here we go, review and create auto scaling group. So it will be created. Here we go. Our auto scaling group has been created with all of these settings. Okay. So it is updating the capacity because if you remember, I have set the desired capacity as 2. So it should launch 2 instances immediately. Let me go ahead and see in the instances section and refresh. See, this 2 instances are getting launched. This is because of the auto scaling group, because I asked it to keep the desired capacity as 2. Let me add the first EC2 also to the auto scaling group that we just created, because this one was not attached to any auto scaling group as of now. So I will attach this one also to my auto scaling group. Okay, so let us add it, new AST and attach. Now all of our EC2s belong to our auto scaling group. So in the meanwhile, let me just confirm by checking this public IP if it is showing the desired result. Yes, it says I'm the first EC2 instance. Let me check the other EC2s if they are able to show it immediately, or I might have to wait for some time. So yes, it is saying I'm the new EC2. Previous one was saying I'm the first EC2. The other ones that we launched with the auto scaling group, they are saying I'm the new EC2. That is confirmed. Now what we have to check. We are not going to access these EC2s directly. We are going to access it through the load balancer. Okay, what we are ready with auto scaling configurations with the CloudWatch. I'll just show you now, and with the EC2s, and the load balancer also is ready. So what we are going to do is we will access the EC2s through the load balancers. it will route the request to our underlying EC2s, and they will be monitored by the CloudWatch, the alarm that got created. And if something is there that is needed to be informed, it will inform the auto scaling, which will increase or decrease the number of EC2s. That's how our architecture here is working. So let me first go to the CloudWatch and show you the alarm that got created. So we go here, let's click on alarms and we'll say all alarms. So we should have a target tracking alarm here. Yes, we have it here. This is the new ASG alarm, okay, that got created when we created the target tracking policy. So it will monitor, okay, and all the CPU utilization will be tracked here, okay. If it is greater than 20 for 3 data points within 3 minutes, then the scale out action will be happening, okay. That is the alarm that got created. Now if we go to the load balancers, our load balancer also is ready. We have to go to the EC2. Within that we have the option. So here we go, load balancers we can find from here. So we should have our load balancer ready here, which we created while creating the auto scaling group. This is a one, okay. And what security group is attached to it? I think I need to change it. Edit security groups. I think the default one, okay, the launch visit one is there. I need to give the LB security group, which I created specifically for this. So it is allowing the HTTP and HTTPS from anywhere. So I'll give this one and done. Now what we are going to do is we'll take up the DNS name of our load balancer and we'll access the application from this, where it is routing the traffic onto our first EC2 and onto our another two EC2s, which has the information as I'm the new EC2. So I will copy this and we'll give it in a new browser, a new tab. And here you go. It is reaching to the first EC2. If I refresh, it is reaching to the new EC2. If I keep refreshing, new EC2, first, new, first, new. Why two new? Because we have two EC2 instances which we created from the auto scaling group, which has this user data where they say I am the new EC2. And we created only one EC2 where we gave the user data as I am the first EC2 instance. So it is evenly distributing the traffic onto them, okay. Randomly request is going on to any EC2s. If I keep refreshing, you can see, and even distribution is happening onto all the underlying EC2s. If I see the target groups, you can see here, listeners also are mentioned, monitoring, anything that is there, you can check about load balancer, request count that is happening, okay. And there we go, target groups we can check that got created under which our EC2s are attached, okay. So this is our target group and this is the information. All the targets that are associated with us are healthy. If we stop a particular EC2, let me go to the EC2 dashboard and stop EC2 which says I'm the first EC2, we will see what happens after that. I'll go to the instances and then I'll stop this EC2 which says first EC2. So I'll stop it and confirm. So it will be stopped soon, and here the status also will be updated for the targets. Let me refresh. As of now it is healthy only, so it will take some time to get updated. Anyway, in the meanwhile, let me keep refreshing and check here. Okay, so you can see I'm not getting the first EC2 already, okay. I'm just getting the both the EC2s where it says I'm the new EC2. So the first EC2 gone. So what happened here is the load balancer never routes the traffic to the unhealthy EC2s. It routes the request only to the healthy EC2s, okay. Because I stopped my first EC2, so it became unhealthy. It load balancer got to know, okay. Now it is routing the request only to the second and the third EC2 which had this user data, new EC2 instance, okay. So I will refresh. Yeah, you can see it is in unused state, okay. So it is This is why it is not routing the traffic to that. So this is how we were able to accomplish this architecture. I hope you have understood this and you will be able to implement this now for your different use cases. Now we will meet in the next video and we'll learn something new. Thank you.